Hello. In this case, we're going to see this question that is part of the module 4.3.3. The modules don't have letters. And it says that if we have a real matrix, they are giving you properties that relate a real matrix, so that means a matrix with real entries, and for example, the relationship, if there is any, between the determinant of A and an eigenvalue, or if you have an eigenvalue of A times A transpose, does it mean that that eigenvalue has to be real? Or if you know the eigenvalues for two matrices, say A and B, and if you're trying to figure out the eigenvalue for this one, does that mean that I just need to multiply lambda times mu inverse, that means this one, to get the eigenvalue for that? And we're going to discuss this, and your options for answers are basically all the possibilities, like from none is correct, one of them is correct, two of them, or all of them are correct. So we'll see what is the answer for this. Okay, so we have our three statements, and let's go over some of the theories. So what I recommend you for these kind of problems is for you to go through sections 4.3, all the sections in 4.3.1, and check for what are the results, theorems, or any claims that have to do with properties of eigenvalues. So for the first one, if you look at 4.3.2, in this module, they tell you that the number lambda, or the value lambda equals to 0 is an eigenvalue of A if and only if A is not invertible. And again, you need to do a little bit of putting together ideas here. We know that the condition for A not to be invertible is the same as having that the determinant of A has to be equal to 0. So when you put these two together, what you get is that the determinant of A is equal to 0 implies that the value of lambda has to be 0. And again, that makes this true. Okay, for the second one, what we have is that we have a result in 4.3.1 that tells me, and this is a theorem, theorem 1, that tells me that if B is or I think they use A, but I want to use B so you don't get confused with these A's. So if B is a symmetric matrix, then its eigenvalues are real. And the other thing that you need to know is that, and we have seen this before, A times A transpose is symmetric. Why? Because if I do A times A transpose of this one, what you do is you flip the order, and this gives you A transpose transpose times A transpose. But if you double transpose a matrix, you just go back to the original, so that gives you A times A transpose, A transpose. And that's how we know that it's symmetric. So these together with this one make this one true as well. And finally, the third one is a tricky one. If you go again through all the results that we have seen in section 4.3, you will see that there is no reference to a property that involves multiplication of matrices and their eigenvalues. There is no such relationship, so because of that, there is no reason for this to be true in general. So this one is false. Wow. So, what is our answer? If you look at our choices, choice D tells me that only 1 and 2 are correct. Or are true. And this is our answer.